Now we're going to look into an example of an exam question. Now we're almost done. We're just looking at two examples, exam questions, and we're done. So the first question. In the diagram below, not drawn to scale, PQ is a tangent to the circle PTSR. PQ is a tangent to the circle PTSR. So that RPQ is 46 degrees, angle RQP is 32 degrees, and TRQ is a straight line. So what we're going to do, we're going to examine all this information there to make sure we understand what's going on there. And I'm going to carry through the thought process as to how you solve a problem like this. So it's not drawn to scale. So if we say it's not drawn to scale, the first we need to know that we cannot use what is known as your protractor. We can't use this device. We can't use this device. This measuring device, this angle device. That's 90 degrees there and 0 and 180 over here. We can't use this device to measure the angles that they're asking us about. Okay, and these are the angles down here they're asking us about. Angle PTR. Why we can't use this device, the protractor? Because this diagram is not drawn to scale. So we have to be careful there, trying to use a protractor to draw that. Okay, so let's analyze the other information. PQ is a tangent. So let's do that. PQ is a tangent. Make sure we understand that. From point P is right here. Point Q is right there. So this line here from P to Q is a tangent. And we can see that because we see the point of tangency right here where this line touched the circle. Okay, so we understand that. And PTQ is a tangent to the circle PTSR. So we have the circle that's described as as circle P moving right around to T to S to R and right back around. We don't really call this the letters twice. So we just call it circle P T R S right around. Okay? All right. Next point is that angle R, this means angle, symbols mean angle. Angle RPQ is equal to 46 degrees. Let's look at that. So moving from angle R to P. Sorry, we're going to move from line R to P, then from line P to Q. And that creates an angle, a turn. So angle RP, line RP I should say, we move from R, which is right there, to P. And now we're going to turn. So we move from R to P. Now we're going to turn to Q. Right down there. So we had R now, moving right on to P and turn to go down to Q. Okay, so this angle they're looking at is right here. This angle. Okay, so this angle here is 46 degrees. Angle RQP, start from point R, go to Q, down to Q, and then go turn at P. Turn to P. So this angle they're looking at is right here, which is 32 degrees. This also told us that TRQ is a straight line. TRQ is a straight line, so it's not an angle. So if you move from T to R, then R to Q, you're not going to have any turn moving from R to Q. So it's a straight line right from T to Q. So let's get it from T, moving on, this is T, move from T to R, straight on to Q. There's no angle symbol like in this case right here. Okay. So we're asked to calculate, let's identify the angles we want to calculate. Angle PT, this is one. So right there. Angle PTR. So from P to T to R. So looking at this angle right here. Do you want to calculate what angle is this right there? Okay, so what angle is that? Okay, so let's analyze what we have so far. Well, what we do notice is that we have a cyclic quadrilateral. Okay, we have T, quadrilateral T, S, R, P. All four vertices are on the circumference. It's a quadrilateral, so we know that the opposite angles will be equal. So we know that angle S, we know that angle S plus, we know angle S plus angle T, this angle right here, and this angle right here will be equal to 180. What else we know? We know angle R plus angle T down here, angle R plus angle T is also equal to 180 degrees. When I say angle T, I'm not talking about this little angle right there. I'm talking about the entire angle there. So looking at that now, we need to find angle PTR. PTR. And how are we going to do that? So we need to look at what we have so far. Okay, what I noticed that this is actually what? A tangent. It's a tangent, and here we have this angle. This angle 46 is between a tangent PQ and between the chord PR. So this 46 degrees is between a tangent and a chord. And what did we know about a tangent and a chord? Okay, from a prior learning we learned that angle between a tangent and a chord is equal to angle in the alternate segment. Okay, so this angle here, from here to here, is same as this angle here. This angle between the tangent and the chord is equal to the angle in the alternate segment. So this angle here, from the tangent to the chord, is pointing right down here. So that's 46 degrees. So our answer to that is going to be 46 degrees. Okay, so let's tie this up a little bit. Okay, so the angle between the tangent and a chord, this is tangent, the chord, 46, is equal to the angle in the alternate segment. So this chord creates this segment here, the minor segment. This chord PR I'm talking about, and this is the major segment. Okay, and so this angle here is actually standing on the same chord P. This angle I'm talking here is standing on the same chord P and the same point P and the same point R. So this angle is standing on the chord P R, in other words. So this angle is equal to the angle that's between that same chord and the tangent. We call it the alternate segment theorem. Okay, so it's equal to 46 degrees. I think I need to write that a little better. So equal to 46 degrees. And the reason is alternate segment theorem. Next one, angle TPR. Angle T. So angle T going to P, and you turn at R, and that should be right here. What is this angle right here? Angle T, P, R. So looking at this angle right there. What is that angle? Okay, so we need to take a little time to think about that. We have, if you look at this angle here, it's a part of a triangle for sure. It's part of a triangle. Yeah. And so we need to do a little thinking about it. But what I can do so far, well, if you look at this, what we have outside here, what I notice is that we have a triangle outside here. Okay, we have a triangle. We have triangle P R Q. So if I should draw that a little bit, I should draw a triangle P. Let's look at it. Triangle P right? This is 32 degrees. This one is 46 degrees. This is P. That's Q. And this is R down here. I can find this angle in it. How do I find this angle? Triangles in a triangle should have 180 degrees. So I can find this angle here. This angle here, in other words. Follow me? I'm right down here. Okay. So what's this angle? Well, if I add up 32 plus 46, I'll do get 78. And then I'm going to take that from 180 degrees, and that should give me 102 degrees. This angle right here is 102 degrees. Okay. Now this angle here is 102 degrees. Okay. And the sum of angles in a triangle. That's my reason. So you put your reason as sum of angles in a triangle. This angle here, so I can find it. If I find this angle here, then I can find this angle here. Okay, so what I will say is in my solution sheet, I'll actually have angle P RQ, angle P RQ from P to R to Q is equal to 102 degrees. And my reason is sum of angles in triangle. Sum of angles in a triangle. Okay. Of course, you're going to write it out in your exam a little bit better. Okay, so this, all right. So now that I found this angle 102, I can find angle PRT. Angle PRT. Okay, so this angle here is what? Is equal to 180 degrees minus 102 degrees, and which gives me 78 degrees. Okay, that will give me 78 degrees. And the reason for this is angles on a straight line. On a straight line. Okay, if you're not be able to see this properly, just notice this angles, angle symbol, angles on a straight line. Why am I saying that? Because this angle here is actually in a straight line with this one over here. And if this is 102, then this is difference. This is 78 degrees. So the difference between 180 and 102 is 78. So angle PRT is 78 degrees. So what we have now is this. So if we have what we have so far is, let's get it. I mean, there are many ways we probably can find certain answers. This is the way I've looked at it so far. So I have 46 degrees here for T, angle T. Angle R, referring to this angle piece here, this little piece here, that's 78 degrees. And so what is this angle here? And that's the one they want to find, angle P, which is T, P, R. That's difference, isn't it? That's going to be 180 degrees minus the sum of 46 plus 78 degrees, which equals to 180 degrees minus, let's write that out quickly. That's going to be 80, that's 120, 124. Okay, 124 degrees. That should give us 30, that's 50, 56 degrees. Okay, let's try that. 6 plus that is 130, and 130 plus 50, 180. Yeah. Okay, so this angle here should be 56 degrees. Okay, so we found that angle here, P, 56 degrees. And don't forget our reason for this is sum of angles in triangle. Sum of angles in a triangle. This is the angle symbol. This is the triangle symbol. Okay, so now we're down to TSR. T to S to R. So we have to find this angle here. From T to S to R. Remember earlier on what was said is that this is a cyclic quadrilateral. Okay, so cyclic quadrilateral. We have a four-sided shape from T to P to R to S. All four vertices are on the circumference. And so the opposite angles add up to 180 degrees. Okay, so angle TSR is equal to 180 degrees minus 56 degrees. All right, and that should be equal to 124 degrees. And the reason for this is that this is the opposite angles of a cyclic quadrilateral. Okay, you can read that, but we can also says sum to 180 degrees. Opposite angles of a cyclic quadrilateral. I think we could stop there, but sum to 180 degrees is also fine. And so this angle here is 124 degrees. Okay. So it takes a little bit of thinking on our part to figure it out. You don't have to put these values in really. It's on your answer sheet. You want to be able to put these answers down, but state the reasons. So if you notice, beside every answer, there's a reason. And even if you didn't just put the answer here, at least I showed the working over here as to what I was doing. Okay, all right, so that's for that. And let's look on to the next question and final question on the circle theorem that I'll be showing you. Of course, you can always practice some extra questions. Exam question 2, the final one. So the diagram below, not drawn to scale, shows a circle with center O. So we have to keep in mind they have a center. This line, the line DCE, is a tangent to the circle. Let's check it out. So we have D to C to E. Okay, so it's indeed a straight line. Is a tangent to the circle, and yes, it is. Point of tangency. Angle AC is 48 degrees. Angle from point A to C to point E is 48 degrees. So we have a turn there. So looking from point A, going on to C, and we're turning at C to E. And that angle here is 48 degrees. The angle there is between a tangent and a chord. And angle OCB is 26 degrees. Angle O, this is angle O here. That's sorry, it's point O. This point C. I'm going to turn to B. Get the angle of 26 degrees. Okay, so let's look at this question now. Seems pretty easy. And so what we have there is we have to identify what we've seen so far, and that will help us a lot. Okay, so what we're seeing a radius, and a radius meets a tangent. And we know that rule, that a radius meets a tangent. So we know this angle right in between here should be 90 degrees. All right, so we know that this is a radius. From the center of a circle to the circumference is a radius. And this is a tangent, and a radius meets a tangent at 90 degrees. So this should be 90 degrees there. So we can put a little right angle there. And obviously on this side is also a right angle because we have a radius, sorry, and then the tangent. So we know this is also over here, should also be 90 degrees. So the angle between this radius and this tangent is 90 degrees, and the radius and this tangent is 90 degrees over there. Okay, so now we found that out. So we know this angle, we can find this angle between here easily, as well as this angle between here. Okay, so this should be 90 degrees in total. So this piece should be the difference between 90 and 48. This piece in between here, because all the way down should be 90 degrees. What other things should we note as well too? All right, so we know this is the chord that divide the circle in a major segment and divide it in also a minor segment. Okay, and since this angle between this angle between chord 48, between the chord and the tangent here, this angle of 48 degrees is in the minor segment, on the minor segment of the chord AC. So the angle in the alternate segment, the major segment that is over at B, should be twice. It should be the equal actually. Angle in the minor segment between the tangent and the chord is equal to the angle over there in the major segment at the circumference. That's the alternate segment theorem. What else do we see in this that we actually know? Well, what we're seeing here is the angle at the center. Angle at the center. Angle at the center is twice the angle at the circumference. So we say angle at O, whatever angle that's going to be, should be twice the angle at the circumference at B. And since if we figure out what B is, we double it to find the angle at O. Since angle at O is twice it. Okay, so let's go on to start solving the problem. So that's a little review as to what we know so far, we studied so far. So here's what angle ABC, going from angle A to B to C. So I guess they want us to find this one first. Angle at the circumference. Okay, now how are we going to find that? Well, it should be noted that the angle at the circumference there can be found by looking at what we looked at early on. The angle between the tangent should come back to your mind. Between the tangent and the chord ABC is 48. So the angle that points over there, the angle in the minor segment, is equal to the angle over there in the major segment. So this is going to be 48 degrees as well. Okay, so that's 48 degrees. And the reason for that is alternate segment theorem. Alternate segment theorem. Okay, so that's 48 degrees. Angle AOC. So angle A to O to C. So this angle here. And now we notice that angle B has both legs standing on AC, and angle O at the center has both legs standing on the same AC. So angle at the center, therefore, is twice the angle at circumference. This angle should be 96. Okay? It should be twice angle ABC, in other words. So it should be 96 degrees. What's the reason? Angle at center is twice angle at circumference. Forgive me on my writing. And the instrument is kind of slippery. Okay, so angle AOC is twice the angle ABC. Angle at center, twice angle circumference. BCD, angle BCD. So we're going to find this angle here, angle BCD, right between here. B to C to D. This angle right there. We already established that this angle from the radius right down to the tangent is 90 degrees. Because the angle in between, the total angle between a radius and a tangent is 90 degrees. So if we have part of it, which is 26, the next part of it should be complementary to 26 to up to 90 degrees. So that actually is 90 degrees minus 26 degrees. And so that should give us a 30 from 90, that's 60. And add on 4, that's 64 degrees. Yeah. And so that's going to give us, yes, 64 degrees. And the reason for that is radius meets tangent. Radius is perpendicular to tangent. Same thing as saying radius meets tangent at 90 degrees. They're perpendicular, in other words. Okay? They're perpendicular to each other. Okay, so now we found that. So this is actually 64 degrees. Next one, angle BAC. Angle BAC. So we look for this angle right here. from point B to point A to point C. So looking for this. So we move from B to A, or driving on to C. So looking at this complete angle here. What is that going to be equal to? Okay, so that might be the only challenging one they can think of. Well, so far we know this entire angle should be, well, it's not really challenging. In fact, it should be actually easy. The angle between the tangent and the chord. If you look it over here, so angle D, sorry, tangent DCE, tangent DCE. I'm looking at chord. We're looking over here. Chord, right? Chord BC. Okay. Angle between it is 64 degrees. 64 degrees. And we're noticing that chord BC is pointing towards angle A, right? Look at it, points at angle A. So this segment over here, so chord BC cuts the circle into two segments, the minor segment, and the angle in the minor segment is 64, and the angle in the major segment over here at B should also be 64 degrees. So angle BAC is equal to 64 degrees. And this is alternate segment theorem as well. Okay, now we're down to angle OAC. Angle OAC. Angle OAC. Now to find angle OAC is a little easy as well too. So let's look at it. I'm going to draw a circle down here. Okay, I think I need to do that a little better. Better job at that. Okay. So what we had there, okay, everything just disappeared. Okay, so let's go back over this again quickly. This was angle. This was 48 degrees. We said this angle over here is 48 degrees. This one here is going to be 96 degrees. 48 degrees because this angle between the tangent and the chord is 48, and so the angle in the alternate segment to this minus segment 48 degrees, which is in 48 degrees. The angle in the minus segment here is 48, 48, and so this angle over here is in the major segment, so it's 48 degrees. So we call this the alternate segment theorem. And this one is angle at the center is twice the angle at the circumference, so it's 96 degrees. Okay, so this one is 48. We already put a reason early on, and this one is going to be 96 degrees. And this one, BCD, B to C to D, this angle right here. Well, this entire angle is 90 degrees, angle between a radius and a tangent. So you have to state it. We have to give our reasons. So this is going to be, 90 degrees minus 26 degrees, and that angle should be 64 degrees. Angle BAC, let's move from B to A to C. Now this angle, so this angle here is 64. The whole thing is 90. 64 plus 26 is 90. Now BAC, this angle right here, is what? Well, if you look at it, this angle here in this segment, because this is chord BC. So we're looking at this segment here in the minor segment is 64 degrees. And so the angle that this chord subtends at the circumference is equal to the angle between the same chord and the tangent in the minor segment of 64 degrees. So the angle that this chord subtending in the major segment is the same as this one in the minor segment. So this is 64 degrees. This angle right here. So angle BAC is 64 degrees. And of course, put the reason. alternate segment theorem. So this one is alternate segment theorem. Alternate segment theorem. And this one was also alternate segment theorem. Okay. This one here was angle at center. Angle at center. Twice angle at circumference. And this was what? Radius. Radius meets tangent at 90 degrees. They're perpendicular. And OAC from O to A to C. So what I'm saying, we're going to draw a circle. Okay. And we have a center of the circle. What we call this line a radius. We also call this a radius. Now these two lines have the same length. So when we draw a straight line going across like that, what is formed is an isosceles triangle. Okay, I think I need to do that a little better somewhere down here. Okay, so what is formed there is this side and this side here. They're equal because this is a radius and a radius. All radii in a circle are equal. So what is formed there is an isosceles triangle. An isosceles triangle of this length is the same. That means the base angles will also be the same. Okay, so what we have in this circle here is that the angle at the center here is 96 degrees. So let's look at it. So let's draw this bigger. (96 degrees). And so, and we know that this length same as this length because this is a radius and this is a radius. So they are the same length. So this angle here must be the same. And so how can we find that? How could we find that? Well, if that's the case, a second, let's tie this up a little bit. I'm sure you already start working it out already, which is really good. Okay, that gives you some time to finish working it out. And so if we have an isosceles triangle with one angle being 96 degrees, what are the other two angles, which are the base angles? If the base angles, this angle here is equal to this angle here, and we know all three angles must add up to 180 degrees, then the base angles must be equal to what? So let's write that out. So we have 180 degrees, and we subtracted 96 degrees. This 96 degrees is not the base angle. It's just the other angle, the bigger angle. We'll take it away from that, and that will leave us with 4 and 10 to this 17, 174 degrees. Yeah. So, okay, this is awful. No, what am I doing here? So 6 from that, take away 7 here, and 6 from that give us 10 give us 4, and then we have 9 from 7, 9 from 17. Let's give us so I've made my mistake right here. Okay, 9 from 7 give us 8, so that's 84. So these two angles must add up to 84 degrees. Because this is 96. Okay, that's 96 degrees. To get 84, okay, to get 180, we have to add 84 to 96. Okay, and that will give us our 180 degrees. So these two angles must add up to 96 degrees. So I'm sorry, my bad, 84 degrees. So what we're going to do, we're going to take the 84 and divide it in two parts, and that will give us 42 degrees. So this angle here is 42 degrees, and this angle here is also 42 degrees. So angle OAC is equal to 42 degrees. Now this is a real long way of doing it, because we could have done that easier by just simply looking at this side. This is a radius, and this is a radius. This is a tangent. So the angle between the radius, I'm moving from the radius to the tangent, that's 90 degrees. And so if this is 48 so far, the next piece must add on to give us 90. So we're gonna find OCA first. OCA, angle OCA, which is equal to angle OAC, because these are base angles of an isosceles triangle. Base angles of isosceles triangle. Right? And they're equal. So once I find OCA, and OCA, angle OCA is equal to 90 degrees minus 48 degrees. And 50 from 90, that's 40 plus 2, that's 42. And therefore, angle OAC is equal to 42 degrees. Okay, so we could have done that the other way around as well too. We don't even have to trouble the fact that this is an isosceles triangle. Well, I mean, we don't have to actually go in this route, taking 96 and divide it by 2. But once we find one, we can find the other one. But we have to consider that, yes, that it is an isosceles triangle, because this is 42. Then we can say, yes, the other angle is also 42. Okay, the last one is OAB, angle OAB. Okay, now that should be simple. Angle O to A to B. Since we found angle OAC to be 42 and the entire angle BAC to be 64, then these two pieces must add up together to give you 64. In other words, if this entire angle here is 64 and this piece is 42, then what is this piece here that they're asking us for? Angle OAB. So we can find angle OAB quite quickly by putting 64 degrees minus 42 degrees, and that will be equal to what? Okay, so that's be equal to 2 from 4 give us 2, and 4 from 6 give us 2, 22 degrees. Okay, and that's about it. Okay, all right. Thank you for watching. This was a long video and I'm tired, but hopefully it was helpful.